This presentation identifies the products that, in our opinion, are new, innovative, and likely to result in substantial savings. And those are kind of the criteria that we use to select these products, these 5 products. You can be the clicker.
Okay.
What we decide to focus on is simply indoor water, because irrigation is a total other matter, which other people have talked about. Huge potential for savings in irrigation, but we're just focusing on indoor water use. But we did say it can be residential water demand or non-residential water demand that you would find in commercial or institutional applications. We want it to be generally available in the marketplace. We know there's some innovative products that are kind of really cool and really innovative, but they're not widespread, they're not well known, and we don't feel that they would have an immediate large impact on the market. So we wanted to find something that was currently in the marketplace, a product or technology. We say that it can be a new approach to an old application, but no ideas. We didn't want anybody to come up and simply say, this is a theory of what would work and what would save water. We wanted to say what actually is where the rubbers hit the road, what has saved water, what has proven that it can be used by anybody out here today or any municipality or agency to save some water. We wanted it to be is that we can readily determine the water savings. You'll notice that we're going to give what we estimate to be the potential savings, and this is what we would call the realistic potential savings in North America, Canada, and the US. And we've got the calculations if anybody wants to find those later, but they're realistic. We're not saying, yes, every single person is going to adopt this and adapt this and use this and save this much water. We're saying in some cases 5% of the people will adopt it, whatever, things like that. But we wanted it so it was real world data, whether it's from the field or the laboratory. You'll see that some are both. Favorable economics, we say favorable. We don't mean it has to be 6-month payback or a 2-year payback, whatever, but it can't be a 100-year payback or 50-year payback. Probably as the technology improves, the payback will improve as well. As Glenn says in his project, the payback, if you did that same project now, would be considerably less than it was when he did it. We wanted to have potential for significant long-term impact. I remember once somebody was asking me about rain gauges that you stick in your yard. And they said, couldn't you actually, as part of the program, after it rains, go out and grab the rain gauge full of water, come in and pour it in your plants, and that would save water? I said, well, theoretically, yes, it would, but that's not significant. I don't think any municipality would put that down as a project, as a program. We said, want to be long-term, we can be regional or all of North America. There's some that deal with all Canada and the U.S. and other ones that only deal with more cold climates, although the U.S. has some cold climates as well, and potable or non-potable water. And so that's how we did that. Now, how do we select them? We worked with manufacturers, industry leaders, talking to people like yourselves, other people in the industry, got feedback from utilities, water agencies, municipalities, talked to other labs, IAPMO, ourselves, other people have done testing, manufacturers. A lot of times they'll do their own testing. We'll take some of their data. We'll use that to develop our own testing protocols. Interview with stakeholders, and you can read the 3 stakeholders there. Basically, anybody who was willing to give us information or our own information, we put that together. And with no further ado,
what we're going to do is go through the 5 products. For those manufacturers in the room today whose product that they think is innovative doesn't appear here, well, so be it. I think there are others who would like to have had us do 10 products, and then we could include everybody. But that's not the case. So I'm hoping that IAPMO chooses to do this type of session on an annual basis, such that each year we can take a look backwards and see what products are qualified, if you will, and fall within kind of our own view of what is innovative, new, and will save water and meet the criteria. So maybe next year. So let's...
as soon as your check clears, your product will get on this list.
Yeah, there you go.
That's what he's trying to say. He's beating around the bush.
But it has to be a big check.
A big check.
Yeah.
Sustainable long-term checks. That's what we're looking for.
Don't laugh. Oh, well, anyway. So anyway, very independent and not exactly off the wall, but we picked some things that we think are going to yield the savings as Bill described. So let's try the first one, high efficiency pre-rinse spray valves. Those of you who've been around The water efficiency arena for a bit of time, at least 5 years, have seen what's happened in commercial food service with efficient pre-rinse spray valves, such that we've gone from a 3.5, 4 gallon a minute valve down to a 1.6 gallon per minute flowing valve used in pre-rinse of dishes in a commercial dish room. But since the California utilities participated in a very large program that retrofitted about 50,000 of the valves in California, about 1/2 of the total inventory, it was proven that these new efficient products performed better than their counterparts that were of higher flow. EPACT legislation was written such that the national mandate, if you will, now sets a maximum of 1.6 gallons a minute, or 6 liters a minute. But since that time, some companies have really done a remarkable job moving beyond that. And now we have valves functioning, pre-rinse spray valves functioning as low as 3/4 of a gallon a minute up to, say, 1.3, 1.4. What we see here is a second opportunity to gain additional savings, not just water, but energy as well, because these valves not only have shown to save 30 to 50,000 gallons a year, they also save several hundred therms of gas a year, because we're talking about hot water applications. I think one of the things we always want to look at is a behavioral modification required to make this product work and save? And in this case, we're basically talking about valves that are already functioning in the marketplace at around 1.3 and showing excellent customer satisfaction and equal performance to their higher flow counterparts.